At the end of this course, we will be deriving the Black-Scholes option pricing formula, and a key ingredient in the proof of that formula is the idea of designing a so-called perfect hedge. So what I'm going to do is work some problems involving odds and perfect hedges based on those odds. So let's imagine you're working as a bookmaker. You're taking bets on a 3-horse race, and you have collected $1,500 on Backow's Blaze, $400 on Faust's Fury, and the 3rd horse isn't named after any Harvard president, it's Arbitrageur. You want to make a 10% profit, and that means you're not going to pay out all the money you take in. When you look at your bets, you see that they total $4,000. Since you want to make a 10% profit, you will pay out $3,600, keeping $400 for yourself. Now, when you quote odds, the odds are always the ratio of the winnings to the amount bet. So odds of 2 to 1 mean for every dollar you bet, you will get a profit of $2. That means if you actually go to cash in a $1 winning ticket, you'd get $3. Your $1 back plus your $2 of profit. So all I have to do is quote appropriate odds for the 3 horses. Let's first deal with the easiest case. Suppose that Faust's Fury wins. I'm going to pay out $3,600. $400 of that will be returning the amount bet. The other $3,200 will be profit to the lucky bettors. They got this by betting just $400, and therefore they will receive $8 of profit for each dollar bet, and you quote odds of 8 to 1. What about Backow's Blaze? Well, you're paying out $3,600, but $1,500 of that is going to be viewed as just a refund of the amount bet. There's $2,100 of profit left, and that was a result of $1,500 bet. And you say, therefore, the odds on Backow's Blaze are 7 to 5. That's a standard sort of bet at a racetrack. You place a $5 bet. If the horse wins, you cash in your ticket and you get $12, your $5 back plus $7 profit. That's why at racetracks there can be odds like 2 to 5 or even 1 to 5 if a horse is an overwhelming favorite. Okay, we'll do the last one. And I still haven't figured out why I sometimes lose the left-hand edge of a line that I'm writing, but I'm gradually getting more comfortable with this new tablet. Okay, in this case, the amount that was bet was $2,100, and only $1,500 of this is profit based on $2,100 bet. According to our definition of odds, the odds are therefore 5 to 7. you will never find odds like 5 to 7 at a racetrack. This would probably be rounded down to 3 to 5 or something like that. That's another way that tracks make extra money, by rounding down the payoffs to the next lowest conventional payoff. Okay, so now you understand how odds work, and we can do something a bit more interesting with them now. So I've been taking bets on Faust Fury. I set odds of 3 to 1, and $2,000 was bet on those terms. In other words, if Faust Fury wins, I have undertaken to return the $2,000 that was bet, plus another $6,000 to the lucky bettors. But now I look on the internet and discover that I can place a bet on Faust Fury over the internet at odds of 4 to 1. So this is a good deal. I've managed to take in bets at lower odds and can place bets at better odds. So I'm in line to make a profit. And what I want to do is to guarantee the amount of this profit. Right now, I'm in a good position no matter what size bet I place, but I can decide exactly how much X I should bet in order that my profit is independent of the outcome of the race. Now, people get confused with this sort of problem because they mix up equating the amount received when the bets are settled and calculating the profit on the entire transaction. You can design a perfect hedge using either approach, but don't mix them up. So I'm going to do both approaches for you. So I'm going to place an internet bet of X on Faust Fury, and now I'm going to design that bet so the amount that I receive when the bets are settled is the same in either case. First case, Faust Fury wins. Well, I bet X at odds of 4 to 1, which means I am going to receive 5 times the amount I bet. But I have to pay out 3 to 1 odds. That's 3 times the amount of bets, 6,000, plus I've got to give back the $2,000 that was bet. Okay, what happens if Faust Fury loses? Absolutely nothing. I don't pay out anything, I don't receive anything, and therefore 5x minus 8,000, that's the amount I receive if Faust Fury wins, has to equal 0, and x equals $1,600. That will guarantee me the same profit in both cases, but I haven't actually worked out the profit. Now let's try the profit approach. If Faust Fury wins, I have a profit of 4 times the amount I bet. However, I have a loss of $6,000 on the bets that I took. What about the case where Faust Fury loses? If Faust Fury loses, then I have received $2,000 from the people who bet with me, but I have nothing to show for the bet of X I made on the internet. So I can set 4x minus 6,000 equal to 2,000 minus x. I get 5x equals 8,000, x equals $1,600. Either approach works. Just don't mix them up. However, in this case, I can figure out that my profit is $400 in either case. 4 times 1,600 minus 6,000 is $400. So I can say no matter what the outcome of the race may be, I'm $400 to the good just by having stumbled across a lucky opportunity to bet over the internet. Now let's try an example that involves some very risky bets. Before all the financial turmoil in 2007, people were inventing all sorts of derivative securities, including things called credit default swaps. Now, the original idea of a credit default swap was perfectly reasonable. You've made an investment in a company that has a small probability of going bankrupt, and you want to hedge against that. You're getting a good interest rate on your bond, but there's some small chance that you'll never get the principal back. So someone says, I'll tell you what, you pay me a small amount, and if this company goes bankrupt, I'll pay you a substantial amount that will offset the losses you get resulting from that bankruptcy. So this is a perfectly good, reasonable hedge. These hedges quickly became abused. One hears stories that derivative security salesmen would go to people, say, managing pension funds for teachers and say, oh, we've got this great deal for you. It will pay you a guaranteed 8% every year, unless Dow Chemical goes bankrupt or Lehman Brothers goes bankrupt. But of course, that's not going to happen. You don't have to worry about that. So, imagine that you found that your investment managers have made a very risky gamble. For $3,000, they purchased a derivative security that pays $100,000 if a certain manufacturer of cassette tape recorders goes bankrupt. This was the era when cassette tape recorders were definitely passé, and this probably was a reasonable thing to do. In fact, analysts now say the probability that this company will go bankrupt is 5%. So you say, 5% of $100,000. My expectation from this investment is $5,000 and I only paid $3,000 for it. Only the people in the teachers union probably won't like my making such risky investments. How can I hedge this? Well, companies with prospects of bankruptcy were fond of issuing junk bonds. Junk bonds pay a high interest rate, but there's always the risk you'll lose your principal because the company goes bankrupt, and you discover that some reel-to-reel junk bonds are still around. The bond is going to mature in a year. Frequently on these bonds, the interest, though not the principal, was guaranteed. So you're sure to get $200 in interest back. The bond has a face value of $2,000, and if the company doesn't go bankrupt, you'll get that back as well. And this bond is priced at $2,100. You say, why priced at 21 when you're going to get 200 plus 2,000? The answer is there's a small probability that this company will go bankrupt. So let's use, in this case, the profit approach. Because we already expect we've got a profit of $2,000. We just want to lock it in. What's our hedge? We'll purchase X of these junk bonds and work out what happens in the two cases. If there's no bankruptcy, well, I paid out $3,000 from this credit default swap, and since reel-to-reel didn't go bankrupt, I got nothing back from it. However, my bonds are looking good. Each bond pays $2,200, but I bought it for $2,100, and therefore my net profit is 100x from the X bonds minus the $3,000 I paid for this gamble on bankruptcy. Suppose reel-to-reel goes bankrupt, what happens? Well, I hit big with this credit default swap type thing. I paid $3,000, collected $100,000. I've got a profit of $97,000. But I paid $2,100 for each of these junk bonds and only collected the interest, so I've got a net loss of $1,900 on each bond, and therefore my net profit in this case is $97,000 minus 1,900x, and I set that equal to 100x minus 3,000. So 100,000 equals 2,000x. X is equal to 50. In other words, if I purchase 50 junk bonds, that's the perfect hedge for this very risky investment that I've already made, and I can check the profit. Make 100 on each of the 50 bonds. I paid out $3,000 for the other thing, and it's $2,000. Of course, I can calculate the profit in either scenario because I adjusted the number of bonds I bought, X, to be the amount that made my profit be the same in both cases. Therefore, I don't have to work it out in both cases. I already know it's going to be the same. Well, you have turned into a derivative trader. Please don't go out and try this on the basis of that one lesson, though.